Right now, somewhere close to you, an animal's brain is processing your existence. A dog on a walk, a crow on a wire, a squirrel frozen mid-step in your backyard. And in that split second, something is happening inside its skull that has almost nothing to do with what you assume it does. You probably think animals see you the way you see yourself. A face, a person, someone with a name and an identity. That assumption is almost entirely wrong, and the real answer is stranger than you'd expect. Start with the crow, because crows reveal something remarkable about how animal brains actually process humans. Researcher John Marsluff ran a now-famous study where his team wore specific masks while trapping and briefly handling wild crows before releasing them unharmed. Years later, when people wearing that exact same mask walked through the same neighborhoods, crows scolded them on sight. Not just the crows that had been originally trapped. Their offspring. Crows that had never personally experienced the event at all. Think about what that means for how a crow's brain processes you. It's not reading your personality. It's not recognizing you as an individual with thoughts and intentions. It's pattern matching a facial configuration against a stored threat template, then transmitting that threat data to other crows through observation and possibly through direct communication. Your face, to a crow, is data. Dangerous data, once flagged, that can outlive the crow that first flagged it. Now consider dogs, because dogs process something closer to us, but still fundamentally different from how you probably imagine. Neuroscientist Gregory Burns ran fMRI studies on awake, unrestrained dogs, something almost nobody had successfully done before. His research found that a dog's caudate nucleus, a brain region associated with anticipation and reward, activates strongly in response to the scent of a familiar human, not the sight. The scent, specifically, of someone they know. That detail should reshape how you picture your own dog looking at you. Its visual processing of your face is happening, but a massive amount of its identification of you is running through smell first. A channel you don't even consciously register is part of the interaction. Your dog isn't primarily thinking, "There's my person," based on your face the way you'd recognize a friend. It's building you, layer by layer, out of scent, sound, and visual pattern combined, weighted far more heavily towards smell than your own brain would ever guess. Here's where this gets stranger, because the question of what an animal thinks when it looks at you depends entirely on what kind of brain is doing the looking. A prey animal's brain and a predator's brain are not running the same background software. Biologist and researcher Daniel Blumstein has spent years studying what's called flight initiation distance, the specific distance at which a prey animal decides to flee from an approaching threat. His research shows this distance isn't fixed. It shifts based on countless variables: your speed, your eye contact, whether you're looking directly at the animal or past it, even whether you're walking in a straight line toward it or an angled one. A deer's brain isn't asking, "Is that a human?" It's running a constant threat calculation loop asking, "Is that shape moving in a way consistent with predation?" Direct eye contact reads differently to a prey brain than a sideways glance. A straight line approach reads differently than an angled one. You are not being perceived as a person. You are being perceived as a vector, a trajectory, a set of movement variables being run through millions of years of inherited threat assessment code. This is why prey animals often relax around humans engaged in unrelated tasks, gardening, sitting still, moving in unpredictable, non-linear patterns, but flee instantly from a human walking a straight, steady line directly toward them, even at a distance that seems harmless to you. Now flip to the predator side of that equation, because it works in the opposite direction. Large predators that have any history of habituation to humans process your presence through an entirely different lens. Not fear, evaluation. Researcher and wildlife biologist Craig Packer has studied how lions in different regions respond to human presence differently based on whether hunting pressure taught them humans were dangerous or safe to approach. A predator's brain isn't deciding whether you're friendly. It's running a cost-benefit calculation, weighing the effort and risk of engaging against the potential reward, shaped entirely by that specific animal's history with creatures like you. None of these brains are thinking about you the way you think about you. There's no animal brain running a model of your inner life, your intentions, your personality, The story you'd tell about yourself if asked. What's running instead is faster, older, and stranger. Scent signatures, movement vectors, facial pattern matching, inherited threat templates passed down through observation rather than genetics alone. And this reframes something you feel constantly without realizing where it comes from. That flicker of unease when a stray dog stares too long. That strange calm when a bird doesn't fly away as you approach. You're not misreading those moments. You're catching a glimpse, a fragmented outside view of a completely different kind of brain, running a completely different kind of calculation about what you are. You've spent your whole life assuming you're being seen. In some sense, you're not. You're being calculated, measured, cross-referenced against threat templates and reward histories built over evolutionary timescales far longer than your own lifetime. The next time an animal locks eyes with you, even for a second, remember what's actually happening behind that gaze. Not a mind wondering who you are. A very old, very fast system deciding in real time what you might mean.